The points P and Q lie on the curve with equation 2x squared minus 5xy plus y squared plus 9 equals 0. The tangents to the curve at P and Q are parallel, each having gradient of 3/8. Show that the x and y coordinates of P and Q are such that x equals 2y, hence find the coordinates of P and Q. Okay, let's have a little look at this then. The tangents at P and Q to the curve are parallel, so let's get dy dx then, and they have gradient 3/8. So here we need to do implicit differentiation, so 4x differentiating with respect to x term by term, minus, this is a product so it's u, so minus bracket, we'll keep the minus outside, and this is the u times v, so it's u times dy dx, that's dv, plus v y times du, which is 5. So that's that one done. Plus, this is a something squared, so the 2 comes down something to the 1 multiplied by the something differentiated, function of function rule, plus 0 equals 0, because the constant differentiates to 0. So this tells us then, let's keep the dy dx here on this side, write a bracket. We've got a 2y here, haven't we? 2y minus, and then when we expand this we'll have a minus 5x is equal to, so that's that term and this term taken care of. Now the other two terms, we've got a minus 5y, move over there to a plus 5y, and then the 4x move over also to minus 4x. So that tells us then that dy dx is equal to 5y minus 4x over 2y minus 5x, and that equals 3/8, doesn't it, the gradient at both P and Q. So what does that tell us now then? More than one term, so put brackets around these things as we move things around. 8 lots of this. Move the 8 up from divide to times on the other side. Leave the 3 as is and move this from divide to times also. So that's what we've got then. 40y minus 32x, when we expand that bracket, 40 minus 32x equals 6y minus 15x. So move the y's over here. 40 minus 6y is 34y. And then move the 32 over. Plus 32 minus 15 is 17x. So 2y is equal to x, which is what we wanted to show. Okay, good. So 2y equals x, or x equals 2y. Hence find the coordinates of P and Q. So if we put that back into this original equation, we should be able to obtain an equation in a single variable. So let's substitute x. It looks like it's leading us to substitute, isn't it? So 2x squared. So 2 lots of x squared, which is 2y now, minus 5xy, x is 2y, times y. And what was the last term? Minus 5xy. The last term was plus y squared plus 9. Plus y squared plus y squared plus 9. So it looks like we're going to get a quadratic here. 4 times 2 is 8y squareds. Minus 10y squareds. Plus another y squareds plus 9. 8 plus 1 is 9, minus 10 is minus y squared. Move that over here, and we get y squared equals, and the 9 leave as is, and I've written it down from right to left. So that tells us that y is equal to plus 3 or minus 3. And so x is, so lots of so's here. X is equal to then, x equals, put it here, 2y is x, so x equals 2y. 2 of these is 6, or minus 6. So there's our coordinates, P and Q. So finally P and Q coords are, well, it would be 3 and 6, and minus 3. Oh, the x is 6 and 3. So around the other way, the xy coordinates here. So let me put them around the right way. 6 and 3, and -6 and -3.